Hey everyone! Welcome back to ZoomInData. And this is episode 36 of our KQL Concepts Deep Dive series, the one you've been waiting for, KQL Interview Prep. Today we cover the most common and toughest KQL interview questions, how to answer them confidently, and tips to stand out. We are keeping everything pure concepts, just clear explanations. This episode pulls together everything from the series. Let's get you ready to ace that interview. Here is our roadmap for today. We will walk through the most frequent question categories, core concepts, dynamic, parse versus extract, union flavors, performance and optimization, filter early, hints, materialized views, time series and advanced, make series, decompose, forecast, production and best practices, cost control, troubleshooting, anti-patterns, and behavioral, scenario questions, real use cases, trade-offs. Finally, answering tips, how to structure responses, use STAR method for stories, and demonstrate production thinking. By the end, you'll have solid answers and confidence to shine. Let's dive into the top questions. First common one. What is the dynamic type in KQL? When do you use it? Strong answer. Dynamic is KQL's flexible container for JSON-like data, objects, arrays, primitives, nesting, perfect for schema on read with evolving telemetry or logs. Access nested fields with dot notation or array indexing, missing paths return null safely. But dynamic columns are slower and use more memory than typed columns. Best practice is flatten early with bag_unpack for objects and mv_expand for arrays. Follow-up question often. Bag_unpack versus mv_expand. Bag_unpack flattens top-level object keys into separate columns. mv_expand explodes array elements into new rows. Show you understand flexibility versus performance. Interviewers love that. Slide 4. Next big one. How do you optimize a slow KQL query? Strong answer. Start with filter early. Push where clauses as far left as possible to reduce rows before expensive operations like summarize, join, mv_expand. Project only needed columns early. Drop unused data fast. Use approximate functions. Decount instead of count, distinct. Approximately _percentile instead of percentile, huge savings at scale. Materialize repeated subqueries are expensive expressions. Apply hints. Broadcast for small to large, shuffle for large, when optimizer chooses wrong. For very frequent queries, materialized views shift cost to ingest. Key phrase to say, push filters left, minimize data scanned and processed. Show structured thinking, measure first, show query. Identify bottleneck, apply targeted fixes. Time series favorite. How do you handle gaps in time series data? Strong answer. Use make series to regularize irregular timestamps into fixed intervals. Includes empty buckets with default, 0, null. Then fill forward carries last value for step-like data, counters, gauges. Interpolate estimates smooth values for continuous metrics, temperature, rates. Regularization is critical. Anomaly detection and forecasting fail on gappy data. Follow up. How does series_decompose_anomalies work? It decomposes the series into trend, seasonal, and residual, removes predictable patterns, then flags points where residual exceeds dynamic confidence bands. Say, decompose first to isolate true anomalies from normal cycles. Shows you understand the full pipeline. Production questions are common. How do you control KQL query costs in production? Strong answer. Filter and project early to minimize scanned data and processed rows. Use approximate functions for high cardinality metrics. Materialized views for frequent aggregates. Shift cost to ingest. Monitor with. Show queries. Track duration. CPU. Scanned data. Alert on spikes. Review top cost queries weekly. Optimize or replace. Follow-up troubleshooting. How do you troubleshoot a slow query? Start with. Show query to see duration, CPU, plan. Identify slow operators. Summarize. Join. MV expand. Check filters early. Hints needed. Test partial. Limit. Smaller time range. Isolate bottleneck. Show operational maturity. Measure. Monitor. Optimize. Alert. Behavioral. Scenario questions test experience. Describe a real use case where you used KQL. Use star. Situation. High volume telemetry, logs. Task. Build fast dashboards and proactive alerting. Action. Union * partitioned tables, materialized views for aggregates, time series pipeline with make series plus decompose plus anomalies, broadcast joins for enrichment. Result. Sub-second dashboards, proactive alerts, 70% cost reduction. Another common. When would you choose broadcast versus shuffle join? Answer. Broadcast when small side fits in memory per node. Fastest. No shuffle of large table. Shuffle when both large or small doesn't fit. Redistributes for scale but costs network. Hint with strategy equals broadcast or shuffle when optimizer picks wrong. Show trade-off thinking. Speed versus scale versus cost. Final tips to stand out. Structure answers clearly. Explain the concept. Give a real use case. Mention trade-offs. End with best practice. For behavioral, use star. Situation. Task. Action. Result. Tell a story with impact. Show production thinking. Always mention cost, scale, reliability, monitoring, not just syntax. Ask clarifying questions. What is the data volume? Query frequency. Latency needs. Shows thoughtful approach. Bonus points. Reference patterns from the series. Union * for partitioned data. Materialized views for aggregates. Time series pipeline for metrics. Broadcast joins for enrichment. Stay calm, confident, and enthusiastic. Interviewers love candidates who think like owners. You've got this. If this series helped, like, share, subscribe, and drop a comment with your biggest takeaway from the whole journey. Thank you so much for watching ZoomInData. It's been an honor to be your guide. Keep zooming in on data, keep learning, keep building. You've got this. Bye for now, and good luck with your interviews.